All right, so we've spent a lot of time talking about how to solve linear equations, and now we're going to move on to how to solve a system of linear equations. So we're going to focus on solving a system of two equations. So there's lots of different ways to do this, but we're going to start by solving by graphing. So you can take a look here. You have two linear equations. One is for company K and one is for company L. And the question you might be asked is, when is it less expensive to use company L? Well, if you take a look at this one here, you're asking, this here is company K, right there, that's company K. And then company L would be this one right here. So what it's really asking you is, when are the Y values for company L less than the Y values for company K? Well, if you take a look at the beginning here, company K, Y values are less than company L. So that's not the answer. But if you go up to this portion up here, well, these Y values are less than the Y values here for L. So here, for K. So here, company L is less than company K. So when you go over 20 minutes, company L will be the less expensive company to use. All right. So a system of equations is when you have two or more equations. And again, right now we're going to focus on just two equations. When you get to algebra 2, you might talk about three equations. And you're going to find values that will satisfy each equation. So your x and y value will be a answer for both of the equations that you're going to be talking about. So when you solve by graphing, you very simply graph both equations on the same coordinate plane. So just like that first graph where you saw two lines on one plane, that's exactly what you would do. And then you're just going to look at your graph and find, where do those two lines intersect? And where they intersect will be the solution to the system of equations. So let's take an example. Here you have y equals 2/3 x plus 4. This is in your y equals mx plus b form. So we know 4 is our y-intercept and 2/3 is our slope. So we can graph this. We'll go to 4, 1, 2, 3, 4, put a dot there. And then we'll use our slope up 2 over 3 in order to graph the other points. So we can go down 2 over 1, 2, 3. And here we have our points. And I don't know how straight I'm going to be able to draw this. Again, drawing this straight is kind of critical to getting your solution correctly, but we'll see how well I can do here. And then let's graph the second equation. So now my y-intercept is -4, 1, 2, 3, 4. And my slope is -2 over 1. So I'm going to go down 2, and then I can go to the right one, or I can go up 2 to the left one. And then I can up 2 to the left one. You can see right there, that's the point that they share. So you see now, if you take a look, well, where do these two lines intersect? They intersect right here at this point right here. So my solution to the system is -3, and the y value is 2. Now, if you wanted to check your answer, you could just simply take this x value and plug it into your first equation and see, does it equal this y value? So let's try that. So I'm going to have y equals 2/3 times -3 plus 4. And so my 3's will cancel out, but I'll still have a -1 here. So I'll have -2 plus 4, which will give me a +2. which is what this y value is, so that's correct. Let's plug it into the other equation and make sure that it's a solution to the other equation as well. So now I'm going to take this here, and I'm going to say y equals -2. Our x value, if you remember, was -3 minus 4. Well, -2 times -3 is a +6 minus 4, which will give us a +2. So that works out as well. So you can see that -3, +2 is in fact a solution to both equations. All right, so now you can have a couple of type of solutions when you're talking about a system of equations. We just looked at the situation where you have just simply one solution. The two lines intersected only at one point. But you can have more than one solution. You could have an infinite amount of solutions if the lines go right one over each other, if the lines coincide. Or you could have no solution if you have parallel lines. So right here you see when the two lines intersect, you have one solution. If the lines are parallel, then those lines would never intersect, so you have no solutions. And if you have one line that lies right on top of the other line, then they share all their points, so you would have an infinite number of solutions. So if you have any questions while you're working through this, please let me know.